We are given this series LCR circuit, and it's given that if you change the capacitance, so he has not given how we are changing it, but if you change it, it's given that the power generated is increased n times. So in how much percentage the cos phi is changed? So we have to relate the power with the cos phi and then hope to get our answer. So let's start with what's given. So also let's draw the phase diagram so we understand what this cos phi means. So we know that cos phi is the angle between R and Z. And of course it also means that it's also the phase difference between the current and voltage. But more importantly, in relevant to our problem, it is the angle between, it's the cos phi is R by Z. Now let's start with what's given. So P2 is equal to N times P1. So here the capacitance is changed. So voltage across resistor in second case whole square by R is equal to N times voltage across resistor square by R in first case. Now what is the voltage across R? So that is V into R by Z. Z is changed, so let's call it Z2. R is still same. So this term V2R square becomes V into R by Z2 whole square is equal to N times. So voltage across resistor in first case is voltage into R by Z1 whole square. So you can see already we have a term of R by Z2 and R by Z1 which we can now relate to cos phi. So let's put the value of R by Z2 to be cos phi 2 and R by Z1 to be cos phi 1, and we get cos square phi 2 is equal to N times cos square phi 1, or cos phi 2 is equal to root N cos phi 1. So now we have this ratio of cos phi, ratio of cos phi's. So this is pretty simple. So percentage change in cos phi will be cos phi 2 minus cos phi 1 by cos phi, that is root N minus 1 into 100. So that's our answer. Also one thing, so like he has not said that capacitance is increased or decreased. So you can imagine it does not matter, because if you, let me quickly explain. So power is VR square by R. So that is VR by Z whole square by R. That is V square R by Z. Z will be this. So V, R and XL are constants. We are varying capacitance. So if this is the case where let's say initially XC was 5 and XL was 10. So you can see if we increase XC to 6, denominator this term becomes 4. And if we increase it to 14, then also denominator remains. So on increasing it to two different values, we still get the same result where the denominator is now less and power is increased. And another example will be when XC is 10 and XL is 5. So we reduce it to 9, then also denominator is 4. We reduce it to 1, then also denominator is 4 square. So it doesn't matter how because they have not given, so we are increasing it or decreasing it and by how much amount, that is immaterial. We are only concerned with this ratio of R by Z, which is cos phi. Now if XC is larger, this phi will be below, but we know cos of phi in first quadrant and fourth quadrant has the same value, so it still doesn't matter. So even if XC is more, this phi will be down. If XC is less, in this case XC is less, so phi will be down. In this case XC is more than XL, so phi will be above the x-axis, but still we are going to get the same values. Alright.